The overall goal of this procedure is to quantify the lag distribution of a bacterial culture to allow discrimination between long lag time and slow growth at the level of a single variant. This is accomplished by first building a setup of an array of scanners that are identified by a single computer.
The second step is to plate a defined colony-forming unit of bacterial culture onto petri dishes containing conventional nutrient agar.
Next, the dishes are placed into engineered holders on the scanners and time-lapse images of the colonies are taken with the scanners. The final step is to run the image analysis using the ScanLag software, which automatically analyzes the images and extracts quantitative parameters such as time of appearance of each colony and growth time of each colony. Ultimately, MATLAB functions are used to generate the lag histogram using this data.
The implications of this technique extend towards diagnosis of persistent infections because it enables detection of slow variants.
To begin, choose a flatbed scanner with an optical resolution of 4800 dpi, hardware resolution of 4800 by 9600 dpi, and the color bit depth of 48-bit that can operate at the relevant temperature and humidity levels. Choose a scanner that allows more than one scanner to be attached to the computer and identified uniquely. Petri dishes have significant volume, unlike paper, which is usually used in commercial scanners. The colonies lie on top of the agar layer, about 5 millimeters above the scanner surface. For most scanners, the colonies will be